चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. In this lab, we'll check the internetworking between LDP and segment routing, and how we'll achieve this internetworking we will achieve with the help of the mapping server. So you can say mapping server is the key component of to achieve the internetworking between the LDP and segment routing. What what it does, it will enable the SR capable node to internetwork with the LDP nodes. And the mapping server, what will do, this will advertise the prefix to SID mapping in the IGP on the behalf of a non-SR capable, non-segment routing capable nodes. What does it mean? That in the core we have four routers P1, P2, P3, P4. These routers are SR capable. These router can support the segment routing, let's suppose, okay, and these router can support mpls also. But P1 and P2, let's assume these nodes are not capable to support segment routing. So what we have done in this topology, on the P1, P2, I have enabled the LDP, but I have removed the segment routing configuration. On the core router, we are running the LDP and SR both, but the by default preference of the label is from the LDP. So I've done the SR prefer. I will show the configuration once we log into the router. So what is the situation now? Between PE1 on these interface, I have enabled on this core router only for the gig 1. Here 0/0/2 means what are the interface which connected with the provider as a router. On those interfaces I have enabled the LDP. So on the PE1 we have a two LDP neighbor, this router and this router. On this P2, we have this LDP neighbor, this LDP neighbor. But in the core, there is no LDP running. All of the internal interfaces, this interface, this interface, this interface, this interface, only SR is running. There is no mpls LDP is enabled. To achieve this, what we'll do, we will configure the mapping server to achieve the internetworking between LDP and segment routing, so we can get the end-to-end labeled path, you can say, okay, end-to-end, so we can get the end-to-end reachability. And we'll also configure the two mapping server one with the P2 router, mapping server 2 with the P1 router. So we'll be able to see how to configure mapping server on the iOS XR box and also in the iOS XC router. And one more reason to configure the two mapping server is if one router goes down in the network, so other can take over the role. So here we will configure the mapping server. In the mapping server, what we'll do, we will configure the prefix SID for this non-SR capable node for P1, P2. As you see, we have a prefix SID for the P1 node is 16001 and for the P2 prefix SID is 16002. So we'll configure this prefix SID for their loopbacks in the mapping server configuration. After that, in the ISS process, we will advertise those SID. And these P1 and P2 router now in this topology are the mapping servers. So P3 and P4 router will become the client. On this client, we have to receive in the ISS process. We will receive dot mapping server advertise SID. By default, receiving ISS receiving advertisement from mapping server is enabled, but I have disabled to show you the how it will work, correct? How we have to enable it if it's not enabled, and how we will see we will be getting the seeds in the ISI database, but those seed not available will be in the you can say forwarding plane. Okay, so we once we enable the configuration in the ISIs to receive the seeds, we will be able to see the mapping server advertise it in the forwarding plane also on the P3 and P4 router. And after that, we will check the end-to-end reachability from P1 to P2. Also, we have, as we've seen in the last video also, we have two loopback interfaces with a part of the customer VRF. From that VRF also, we'll check the end-to-end reachability. Let's jump to the configuration part. So this is your first node P1 router. This is the only LDP capable node. So we are only running the LDP. No SR is there. Let me show you the configuration. I already done the configuration for with respect to LDP. router ISS first. Okay. So this is the config related to ISS. Router ISS core is running, and we have enabled the LDP and place LDP auto config. Even the I've done the config and place LDP also. Okay. You can see embrace LDP. I have called the both of the interfaces we connect with the core router, and there is no segment routing configuration now is labeled in the ISS core process. Also, there is no seed available on the loopback 0 IPv4. Let me remove this global block configuration also. Segment routing block. Let's jump to the other node. TE2 node also. This is also LDP only node. I have disabled the segment routing from this node also. This is the ISS config. You can say router ISS. There is no segment routing MPS enabled. There is no prefix-sid node enabled on the loopback. And show run segment routing. Global working node there. And if we check with respect to one more thing, we have to check is LDP neighbor. So we have an LDP neighbor with the two core routers. Show mpls LDP. I have enabled the mpls LDP. Only interface, these two interfaces are connected with the core routers. Let's jump to the core router now. So this is our P1 router. On this P1 router, we are running LDP toward the provider edge router 1 neighbor. So we have an only single neighbor. To do the show ISS neighbor, it's connected between the PE1, P2, P3, and 111 IP address is the PE1. So with the PE1 non-LDP LDP only running node, we have enabled the LDP only. And here on the show run, in the core I have prefer the SRMPL. This is the command. In the segment routing embrace config on the IOSXE set attribute SR label preferred. If you are running on any node on IOSXE LDP and SR both, so we have, if we have to give the preference to the SR, so we have to done this configuration. As we have seen the topology, this will be our mapping server also. So let's jump to the configuration here. What we'll do, we will configure the mapping server. Segment routing, mpls, go to the, here is mapping server. Under the mapping server, we have to go in the prefix-sid-map. Under the prefix-sid-map, to the address family IPv4, and then we'll advertise the label prefixes for the non-SR capable node. So they are the two non-SR capable node P1 and P2. P1 loopback is 1.1.1.1/32 index, and we have decided prefix it for the P1 16,001, so I'm putting the index 1. Same way the P2 loopback is 2.2.2 and prefix it decided by the 16,002. So this is the only one thing required here. Exit and exit. So we have done the configuration in the segment mapping server, Prefix-sid-map, and we are advertising node seed for P1 16,001 and 16,002 not it for PE2. Let's advertise this prefix map in ISIS. This segment routing prefix map advertise local. This is the command is required. So on the mapping server, there is a two-step configuration required. First, we need to define the mapping server configuration. After that, we need to advertise in the ISIS process. Segment routing prefix map advertise local. Okay, so this is let's jump to the mapping server 2. So this is our second node with the mapping server 2. The configuration here, the P2. This is the configuration ISIS. Here we have done the segment routing mpls SR prefer. This is the core node. And we have only single mpls LDP neighbor with the P1 router. Now let's do the interfaces segment routing element. Segment routing server sid-map LDP for advertise index start index 1 and similar way for the PE2. This is the loop back of PE2. Time to do. Let's advertise this in ISS process route ISS core segment routing family IPv4 segment routing prefix-sid-map page local. So this is the application in P2. So now we have completed the configuration for the mapping server 1 and 2. Okay, so in the ISS process we have advertised the prefix-sid-map, and on the segment this is the mapping server configuration we have done. For the PE1, PE2 labeled advice. For the PE1 16,001 and for the PE2 16,002. These are the index and this is the block range from the 16,000 plus 1, 16,001, 16,000 plus 2, 16,002 for this. Let's jump to this. So now we have to complete the configuration of the client. P1, P2 as the mapping server 1 and 2 and P3 and P4 node with the mapping server client. So in the client what we have to do is show run, let me show the show run show router ISS. So this is the command we have to enable segment routing prefix-sid-map receive enable. By default this command is enabled. I have to just to show you that how to receive. I will disable this. Our segment routing receive. So let me do the no to this. But before that, let me show you what is happening now. If you see the show mpls following table prefix for the P1 loopback, suppose so we have an unlabeled part. There is no label. Similar way, if we see the 2.2.2.2/32, here also we have an unlabeled. And this entry is showing because the P3 directly connected with the PE2 and we have an LDP neighbor. This is the reason showing the pop. This is the LDP. Like this is the P2 is directly connected for this label, for this prefix. For P2 loopback only we are checking the entry. PE1 is showing the unlabeled path. If you check the show PE1 mapping server 1, the mapping server 1, the database here you can see we are getting those entry checks starting index for the PE1, PE2 we have an assets. In the same way, P2 is our second mapping server. In the database also, we are getting the seed for the loop back 1.1.1.1 P1, P2. We are getting the entries in the database, but there is no entry in the mpls forwarding plane. Let's see for the 16,001 and 16,002, there is no entry. 16,002. What we'll do, let's enable that. Ultra SS core test family IPv4 no segment routing prefix-sid-map receive disable show. So let's now check the show mpls forwarding. We rerun those one. So now we have entered this. Check the show mpls forwarding 1.1.1/32. Here we have an entry earlier to the unlabeled path. Put it also, which was earlier. The same way we have to done on the P4 node. Let's jump to P4. So this is our last and final node. Now let's see the show run first. So here is we have prefer the SR in the segment routing configuration. And here I have disabled it. Let me enable. Here also situation the same. If you do the show mpls forwarding, if there is no seed for the 16,001, 16,002 in the forwarding table. Show mpls forwarding 1.1.1.1/32. Showing the no label. 2.2.2.2 showing the pop. As this is the directly connected, and we have an LDP neighbor on this. That's the reason it's showing the pop. Okay, so let me enable it. This is in a client. In the client, we have to receive the seeds from the mapping server. So we have to see now. Forwarding table first. So here we have an entry now. Now we have an table path for this. So that's it. Let's jump to the PE1 to check the reachability, to check the end-to-end reachability. Here we are now on the PE1 to check the end-to-end reachability. From this node, find plus LDP neighbor. So we have here the two LDP neighbor between the P1 and P2 are the two neighbors. There is no segment routing here. The ISS process. Okay. So let's ping mpls IPv4 2.2.2.2. This is the IP address of P2 sources. This loopback. Effect generate. So here we are able to ping. Let's do the trace route. IPv4 2.2.2.2/32. Generate. Here we can see that this is the 24,000. This is the ISR range for the label. from the LDP, and this is the prefix seed we are getting, and this is the PHP router. Same way, like if we check the route in the VRF, show route VRF blue, so we have a route in the blue, trace route VRF blue. Let's trace out this prefix. So we have an end-to-end reachability. So in this video, in this lab, we have checked how LDP and SR can work together, and how with the help of mapping server, we can get the internet working between LDP and SR. Thank you.